In chapter 4.7, we're going to look at overlapping triangles. And one of the rules that you guys definitely want to know is anytime that you have overlapping figures in geometry, a lot of times it's going to help to take those overlapping figures and separate them out into separate drawings. So let's take a look at problem number 1, which is identifying common parts. And the problem is, what common angle do triangle ACD and triangle ECD share? So you can see that those two triangles are in fact overlapping and they've been drawn out for you. Now the first step is to identify the different triangles. And once we've identified the different triangles, then we can separate the triangles to see the individual angles and segments. So when we do that, you can see now that we've got two different triangles that are in front of us. So now we're looking for which common angle do they share. Well, in the top triangle, you can see that the top triangle has angles AD and C, and the bottom triangle has angles BE and C. So which angle is present in both triangles? That would be angle C, and that's how you do problem number 1. Okay, for problem number 2, we're going to be looking at what are the common parts in two overlapping triangles. So here you can see that we've got triangle ZXW and triangle YWX. And we're given that angle ZVW is congruent to angle YWX, and angle ZWX is congruent to angle YXW. What we want to prove is that segment ZW is congruent to segment YX. So we're going to look at separating the triangles into two different triangles. And now you can see that we've got the two triangles with triangle ZXW and triangle YWX. We're then going to go ahead and put in our given markings. And so we've got angle W is congruent to angle X, and angle X is congruent to angle W. Then we know that the shared side was segment WX, and that was WX is congruent to segment XW by the reflexive property. Then we know that the two triangles are congruent because we have ASA congruence, which then means that segment ZW is congruent to segment YX. That's the segment that we were looking for, or the two segments we were looking for. And they're going to be congruent to each other by CPCTC. For problem number 3, we're given a fairly complicated drawing. We have 6 possible triangles in the drawing that we're given here. And we are looking to prove that triangle GED is congruent to triangle JEB. So the first thing that you're going to do is identify the target triangles. So I've done that here by changing those two triangles to green and orange. Now the next step is going to be to look at the given information that we've got. And that is that point E is the midpoint of segment AC and segment DB. So what we're going to do is we're going to take a look at segment AC, and we know that segment AE has to be congruent to segment EC because E is the midpoint of the entire segment. Then, because E is also the midpoint of segment DB, then we know that segment DE has to be congruent to segment EB as well. So at this point, we've got a couple of different segments that are congruent, but not enough information yet to be able to prove any sort of triangle congruency. The next step that we're going to do is we're going to say that angle CED is congruent to angle JEB by vertical angles. So now we have a side and an angle, so we either need another angle or we need another side. I'm going to go ahead and put in that angle GEA is congruent to angle JEC, also by vertical angles. Now, this isn't on the two triangles that we're trying to prove congruent, but it will help us to get to where we need to be. The next step would then be to say that angle AED is congruent to angle CEB by vertical angles, or you could say that they're congruent by the angle addition postulate. So either one of those two reasonings will be good enough to cover that one. Then the next step would be to say that triangle AED is congruent to triangle CEB by SAS. So once we know that those two triangles, the two large triangles, are congruent, then we can say that all of their parts are congruent by CPCTC. This includes angle D and angle B. So if angle D and angle B are congruent, then what we see now is that we've got ASA congruence. So we know that triangle GED is congruent to triangle JEB by ASA. In problem number 4, we're going to do the same sort of thing that we did in problem number 3 and problem number 2. And that again is separating overlapping triangles. This time we're going to try to prove that segment BX is congruent to segment DX. Now in this particular diagram you've got one large triangle, then you've got two smaller triangles that look to be congruent to each other. Then you have what looks to be an isosceles triangle. And then if you combine the smaller triangles with the isosceles triangle, you get two more triangles. So there's a lot that you could separate out here. What I'm going to do is go ahead and separate this into the two triangles that look to be congruent, and then the two large triangles, not the isosceles one. I can keep the large diagram where it's at. And if I need to do any markings on the isosceles, or what appears to be the isosceles triangle, I can do it on the original diagram. So we can now see the individual angles and segments that we're looking at. And we're going to start with our given. So our given is that angle, or segment CA, is congruent to segment CE. Now this is on the large original diagram. So now we can see that we had an isosceles triangle on the original diagram. If we know that we have an isosceles triangle on the original diagram, then that tells us that angle A and angle E have to be congruent by the isosceles triangle theorem. We can then also mark angles A and E on our two smaller triangles down at the bottom that we've separated out. The next step would be to say that segment BA is congruent to segment DE by given. So that then tells us that we've got segment BA on both the original diagram and on the smaller triangles. We know that those two segments are congruent. Then we already know that since AE is a part of the original diagram and the two smaller ones at the bottom, that segment AE is congruent to segment EA by the reflexive property. So what we've just done is we've proven that the two triangles at the bottom of the diagram are now congruent. Now we're looking to see if we can prove that BX is congruent to DE. So the next step would be to then say that triangle ABE is congruent to triangle EDA by SAS, which we just figured out after the reflexive property, which then tells us that all of the corresponding parts are now congruent as well. That means that angle B is congruent to angle D. And we can mark that off on the two triangles that are scalene triangles that are kind of connected together there at point X. So once we've got that, then we need to look and see if we can do anything else. Well, since these two triangles are connected at point X, we know that angle BXA is congruent to angle DXE by vertical angles. And if we then know that those two angles are congruent, we can then say that those two triangles are congruent, that triangle BXA is congruent to triangle DXE by AAS congruence, which then means that all of the individual parts of those two triangles are congruent, which then tells us that segment BX is congruent to segment DX by CPCTC, and there's the proof.